design, a method in which we will select the design of the airfoil for the particular aircraft model. So, introduction to main wing design. In this lecture series, we will deal with the design of main lifting surface of the aircraft. This is the logical next step in the design of a conceptual aircraft, since the weight and the wing loading that matches the mission requirements have now been determined. So in this most case, the main lifting surface is a single wing. The design of the wing consists of selecting the airfoil cross section shape, uh, the average chord length, the maximum thickness to chord ratio, the aspect ratio, the taper ratio, and the wing sweep angle, which is defined for the leading edge as well as the maximum thickness line. A schematic representation of the wing cross section has been shown in the figure. The effect and selection of each of these parameters is presented in the following sections. In this lecture series, a majority of the information used in the calculation of the airfoil cross-section shape comes from literature survey or experimental data. And one of the key reference that has been used is the book by Abbott termed as Theory of Wing Sections. So the airfoil shape selection. Now a good starting point in the selection of airfoil cross section is to consider the cruise condition. There the requirement lift equals to the weight, so that we have CL at cruise is equals to Q into W by S, that is dynamic pressure into wing loading at cruise. At this point of time, with long range aircraft, the weight of the aircraft can change significantly from the starting of cruise to the end of the cruise. So we assume that the cruise altitude and speed remains the same. This means that the required lift coefficient changes during cruise. The average of the required lift coefficient during cruise is referred to as design CL. So in order to have the maximum range during cruise, the drag needs to be minimum. So the airfoil shape is then selected based on two criteria. They are, it can provide the design CL in level flight condition, and the range of CL values from the start of cruise to the end of cruise is within the drag bracket. So the design worksheet that we'll be having for this calculation, uh, it is usually segregated into two parts: design parameters and airfoil data. So the most important data that are needed for the wing design calculations include CL max, CL alpha, location of the aerodynamic center, zero lift angle of attack, base drag coefficient, leading edge radius, and extent of the drag bracket. So we have our design parameters. Now the determination of the wing loading, that is W by S, for different flight phases is mentioned as it was determined before. So the wing area comes from the spreadsheet based on the weight and wing loading at the start of the cruise. The design CL comes from the given equation that we have in our wing loading estimation. Now, this needs to be calculated based on the wing loading at the start and end of cruise. In the selection of the airfoil section shape, the drag bracket needs to be wide enough to encompass the change in CL value. And you can note that the new parameters that are first used in this spreadsheet are the leading edge sweep angle and the taper ratio. These are selected on the basis of historical data, and a plot has been presented in the subsequent slide. Now, we may note that we have CL cruise at start and CL cruise at end. So based on this, 6 series airfoil which can be chosen because they are generally exhibit good performance at both subsonic and supersonic Mach numbers. So based on the wing design and dynamic pressure, the CL cruise has a range of 0.448 to 0.426. So we can select any NACA series airfoil which provides a drag bracket which encompasses this range of CL. So for any value that we have got, we need to make sure the NACA series encompasses the CL at cruise and CL at end data. So further calculations has been done with respect to the mentioned formulas. An important factor and very confusing parameter is M effective. How do we determine that? Here, the leading edge sweep angle LE is determined to be 10 degree was set so that the effective Mach number at the leading edge would be slightly subsonic. So this was verified in the calculation portion of the spreadsheet where M effective was found to be 0.59. It is also important to note that irrespective of the formula, the leading edge sweep angle needs to be varied and it has to be found that the maximum M effective is obtained with corresponding leading sweep angle. So we got the maximum M effective of 0.59 at sweep angle of 10 degrees. And further using this M effective value, further calculations were done. Here the selection for sweep angle and with respect to design and thickness has been mentioned. A reference from Thomas C. Cork has been done and Raymer. These plots can be easily found there. Again, one of the key design drivers for the selection of a taper ratio is to minimize the amount of lift induced drag. From lifting line theory, for an unswept, untwisted wing, an ellipse shaped wing planeform gives the maximum drag. Such a wing gives an elliptic spanwise variation in the lift. This can be approximated reasonably well with a more simply constructed trapezoidal wing with a taper ratio of 0.4. So this has been illustrated in the figure. The taper ratio for a trapezoidal wing which gives the maximum lift induced drag is slightly dependent on the aspect ratio and more slightly depend on the wing sweep angle. So this is shown in the next figure, which plots the taper ratio of the trapezoidal wing that best approximates as elliptic spanwise lift distribution as a function of sweep angle. Come to the end of this section. The takeaways from this is how to select the wing. So considering the value of CL at cruise start, CL at cruise end, this range should be covered by the NACA series. Another important factor was the selection of M effective. Using the formula and varying the sweep angle, we need to make sure that we obtain the maximum M effective value. Using that, further calculations can be done. So I hope you get to select your NACA series airfoil for your desired aircraft. Any doubts, you can always put up a comment as a question and I'll try to respond to it as soon as possible. Hope it was a helpful session. Thank you and take care.